There's no doubt nuclear power will play a big part in the UK's future energy needs. Scientists like Charlotte Bailey will be crucial. Charlotte is in the second year of a 3-year apprenticeship at Sellafield in Cumbria, and it's her job to find out if anything's going wrong at the plant.
I feel proud to work here because what we do is we make sure that everything's safe, make it safer to the environment and make everything more efficient.
Sellafield employs over 10,000 people, but no longer produces nuclear power. Instead, it recycles and stores tons of nuclear waste produced by nuclear power stations around the world. So Charlotte constantly needs to check for contamination. What's remarkable about Charlotte is she didn't even study science to A-levels and went from working in McDonald's to the nuclear industry via her apprenticeship.
I went to start my apprenticeship at Sellafield with no science qualifications at all, and they're putting me through them all. They're teaching me everything I need to know as I go along. The people that I started with, there was 7 of us started. Half of us didn't have any science qualifications at all, and the other half, in fact, only one of them actually did A-level science. I think it was chemistry. It just shows that you can start it anytime you want.
Charlotte works in a high-security area and needs to be aware of the potential dangers of the compounds she handles.
I work in plant control area for analytical services. The purpose of the testing is to check that plant, whichever one sends us samples, is running okay, that everything's safe, everything's within limits, and if anything is out of limits, we tell them and they can sort it out straight away. We do a lot of pH testing. We test for the amount of solids in a sample, and that could be undissolved or dissolved solids. Nitrates, phosphates, chlorides, everything you could think of really, we test for.
Skills in science, technology, engineering and maths lie at the heart of her job, which is why her role as a STEM ambassador is so valuable. Today she's returning to her old school, St Benedict's Roman Catholic High School in Whitehaven, to run a science club with Year 9s. She's devised a series of explosive lesson starters to hopefully get the pupils enthused about science. This is the first time Charlotte has taught secondary school pupils, and unable to bring Sellafield and its radioactivity into the classroom, she's opted in this first session to wow them with some explosive experiments. Science teacher Victoria Stevenson is on hand to make sure everything goes to plan.
Me and Charlotte have had a talk previously to say about what experiments are going to happen, and I'm there to make sure that nothing goes wrong and that they're all carried out safely.
Charlotte gets the lesson off to a fiery start, bubbling methane through washing up liquid to make a flammable froth. Charlotte then gives the pupils the chance to experience holding a ball of fire.
So who wants to go? Does anyone want to go? I'm going to bubble some gas through it. You've got your hands wet. I'm going to scoop that off and have flat hands. Stretch them out.
I enjoyed it when the people took the bubbles and set them on fire because I wasn't expecting it to go into such a big flame.
That one was bigger that time, I think. Yeah.
With Charlotte being a former pupil, then I think they probably find it easier to talk to her and ask her questions. And it's not a teacher saying, you should do this, you should do that, you should go to university, you should have an apprenticeship. It's somebody who can relate to them because she was in their situation only 5 years ago.
It's no accident the Sellafield plant is on the coast, away from large population areas. But for Charlotte, that's an added attraction to the job.
I didn't want to move away from Whitehaven, which is why I decided to do the apprenticeship, because I didn't want to go to university and I didn't want to have the sort of life, like a busy life in cities. And Whitehaven's it's a quiet place, but it's where all my friends live, and I don't expect any of them to move to a city, even though they're there for uni. I think everybody's got a secret soft spot for this place. Salafield's had a massive impact around here. It's created so many jobs, a lot of science and engineering jobs, which we do get a lot of people coming from away to work. And it would be nice to have kids who grew up knowing that Salafield's here to want to go into them sort of jobs, and that's a big part of going into schools.
In this experiment, Charlotte is using hair dye to create a volcano.
Right, we're going to do this reaction with some hydrogen peroxide and some red lead. This red lead is toxic, so this will basically break down into oxygen and water. The red lead will actually speed up the reaction, so it's called a catalyst, and it'll basically make the breakdown to oxygen and water quicker. Seeing them react and the look on their face, obviously it means that they've enjoyed it, and it means that we've got a point across, or it means that what we're doing it actually means something to them.
But it's not all fire and brimstone, as Charlotte demonstrates the secret to making perfect bubbles.
Has anyone ever had bubbles that you buy from a shop and it runs out? Yeah, and it runs out and you try and make your own and it's never as good. Well, that's because you need some of this in it, and this is glycerine. And what it does is it makes the bubble thicker so that it holds its shape more, it doesn't pop as fast. If you get the mixture quite right, it could bounce on the table.
Charlotte's made 3 different solutions, one with 1 part glycerin to 2 parts washing up liquid, one with equal amounts of both, and one with 2 parts glycerin to 1 part of washing up liquid. She wants the students to work out which one is which.
I think that's got the most glycerine in it because it bounced on the table. Just feel it. It's like just go like that. It feels hot. It feels really like slimy, doesn't it? Washing up liquid and glycerine change the elasticity of the surface. Oh, it bounced. So one makes it more elastic and the other makes it less elastic. So the one that's less elastic will bounce, which you're just seeing on the table.
Okay.
In my free time, I play a lot of netball. It's good to keep fit and it's good to do something that you enjoy. I think my role as an ambassador is quite important because the amount of kids that I've spoke to that have said to me, I don't like science, I hate it, it's dead boring. It's good for me to say to them, I didn't like science when I was your age, and then the things we show them when we're in schools lets them know and lets them see the other side of science outside of school. The red lead reaction with the hydrogen. I don't particularly try and say it like, oh, it's not what you think, it's not boring, like I've got a life, because I think kids are really clever and they can tell when you're trying to make them change their mind. Who's actually, show of hands, wanting to get a job in science? So, you want to? You always want to get the kids to think of things that they wouldn't normally think, like stimulate what they're thinking about in terms of chemistry and science and even mechanics, because it's science and technology as well.
Next, Charlotte's chosen to wow them with the explosive properties of alcohol vapour.
So this is propan-2-ol. It's an alcohol that just gets swelled around so it coats the inside and then the excess is poured out. The vapours are trapped inside and then it can be lit. So I need a volunteer. Anyone want to do it? You want to come over? So what you're going to do is I'm going to light this. You'll stand far enough away just so you can hold it. Here you go.
Remember how I told you to hold a splint?
In this experiment, Charlotte shows the explosive power contained within a humble jelly baby.
This is potassium chlorate, and we're going to heat it up until it goes molten. Then when we add the jelly baby, what's going to happen is all the energy and the sugar inside that jelly baby is going to be released, and that's basically what happens in respiration inside your own body. Obviously more controlled than the fire that comes off these, but that's basically how we get our energy. So you can see it's starting to melt and go molten.
It smells a bit like candy puff.
See, I think it smells like burnt toast.
I like the screaming jelly babies because it was like really colourful and it made a really cool sound.
Charlotte rounds off the experiments demonstrating the science behind a chip pan fire.
So the oil's getting heated up, just like with a normal chip pan. If you leave it on for too long, the oil gets too hot, starts giving off vapours, and it's the vapours, because of the heat, they're just sitting on top of the layer of oil that actually ignite and you get your chip pan fire. So you can see a little bit of smoke coming out. What happens when you put water on it?
Big ball of fire comes out.
Water, is it heavier or is it lighter than oil?
The oil goes to the top because it's like lighter.
And what temperature does water boil at?
It's 100 degrees.
And what about oil?
Well over 100.
So what happens when the water touches the already hot oil? Imagine that maybe 10, 15 times more fire than what you've just seen. So what do you not do if your pan is on fire with oil in it in your kitchen?
Put cold water over it.
You don't put water on it. What do you do?
Throw the damp cloth over the top of it to deprive it of the oxygen.
Yeah, you deprive it of oxygen so that the flames go out.
I think because it was a smaller group, you felt more involved and you didn't feel as nervous to join in and things, and overall it was really good.
If somebody's umming and ahhing, should I do science, should I not do science, what options am I going to choose later on in school, then if you do something like this, it can really make the mind up as to what direction they definitely want to go in. There's a focus for the day. It's not just another science lesson where you've got to talk about this because Miss said you've got to talk about this today. So it gives them an opportunity to do something different.
I thought today was really good. We learned lots of practical stuff and things that would also be useful in real life.
The most fulfilling part about doing it is seeing the people that are already that little bit interested and helping them think of ways of getting into that sort of industry. So I would tell them about the apprenticeships and things like that.